Alright, welcome back. In this video we're going to look at bitwise operators, and before we start we're just going to have a little bit of a recap on what's here. So early on we knew that we could specify our literals in different ways, such as ASCII characters. We can specify them as hexadecimal, we can specify them as decimal, and we can also specify them as binary. And to specify them as binary, we just put this 0b in the front. We also remember that we had integer types, and they hold whole numbers. So they included char, short, int, and long. So all of these types hold a whole number. Once again, I'll remind you that just because this is called char doesn't mean it's the only type that can hold an ASCII character. All of them can, but considering an ASCII character is only 8 bits long, this is the most suitable type to use for ASCII characters. But all of these types are just holding a whole number, so a char is perfectly suitable for holding a whole number. Okay, so don't get confused by that word char and just think that it can only hold ASCII characters. Okay. The other thing here that we've added is unsigned. So basically that means that these numbers have to be positive, so they're all positive integers. Now, the reason that with Bitwise for what we're doing, we're only going to consider unsigned is because we're looking at each individual bit, and we remember that the most significant bit is always the sign bit. And we don't really want to change that and confuse ourselves while we're trying to do bitwise operations. So for us and our bitwise operators and our operations that we'll do on those, we're just going to always use unsigned for our labs and our content. Okay, you can look at bitwise operations for signed in your own time if you're interested. Alright, the other thing here is that we've got two different sizes. So char holds 8-bit numbers, okay, so that's 1 byte, whereas a short holds 16-bit, which is 2 bytes. And this is why in the literal I've only specified 8 bits here, and I've specified 16 bits here. I could write 16 bits in this first one, but the top 8 would be cut off and we'd lose them. So I only specify 8. Alright, so now we're going to have a look at our bitwise operators. And so we return to the big list of operators that we had earlier. And our bitwise operators include this one here, these two here, and these 3 here. Okay, and we'll go through each one of them one at a time. So we've got an example here, and we've got our 3 variables, and the first one has the number 1100, 1100 in binary, and so on and so on. So we have that here, and we get to this new variable, and we're going to put this value in it. And we'll see this operator right here. Okay. So this operator here is called a right shift. Okay. And how it works is it takes this value and it shifts it 2 bits to the right, or whatever value is here. So if it was 3, it'd be 3 bits to the right. So if we have a look at A, and if we shift this all 2 bits to the right, we get 110011. And the reason that we lose this part here is because remember that the start of the number starts here, and so if I draw this out, this one's going to pop off the end, and this one's going to pop off the end. Now, we've still got 2 bits at the top, and they'll always be inserted with zeros. Okay, so when we're shifting, it moves everything across, and it introduces new zeros, and if it reaches too far to the right, you just lose it. Okay, so what would be stored in D is going to be 0, 0, 1, 1, 0, 0, 1, 1 in binary. We then have the next one here, which I think you could work out, and this is going to be our left shift. So here we start off with our variable A, which has this value here, and we're going to shift it to the left. Now, remembering that a car can only store 8 bits, it will shift the top 2 off and we'll lose them, and it will insert new zeros at the bottom. So we get 0, 0, 1, 1, 0, 0, 0, 0. So this is our left shift, and it just shifts everything across. Okay, so we get that value there. Now if you want, you can take the time and convert these to decimal and see what is happening, but we're not too worried about that right now. We only care about what's happening in binary. The next one, well, the next 2 look very similar to something you've seen before, which is your AND and OR. And you need to be really careful not to confuse these, because they do something similar but in a very different way, and you'll get a very different result. So a single line is a bitwise OR. So remembering that with our bitwise operators, with our AND operator, if this is not 0 and this is not 0, it will give 1, and if either of these are 0 or both are 0, then it would give 0. 0 being false, 1 being true, and anything that's not 0 is considered true. So the bitwise operators work differently than this, okay? And if you confuse them, you will not get an answer that you expect, okay? So be really careful here. And if you do have a condition where you are using and you're having problems, that's something you should check. Am I using it correctly? Have I got AND, or have I got bitwise AND? Okay, so if you only see one of these, it's a bitwise AND, or, and we'll talk about the other one. So this is a bitwise OR, and how it works is it doesn't do the OR between the whole variable and the whole variable like it did before. Rather, it does the OR on each individual bits between the variables. So let's have a look at an example with this one here. So we've got A or B. So we take A, and we take B, which is 0, 1, 0, 1, 0, 1, 0, 1. So how this works is this is an OR, but we need to do it with every single bit. So 0 or 1 would be a 1, a 0 or 0 would be a 0, a 1 or 1 would be a 1, a 1 or 0 would be a 1, a 0 or 1 would be a 1, a 0 or 0 would be a 0, a 1 or 1 would be a 1, and a 1 or 0 would also be a 1. So this would give us 1, 1, 0, 1, 1, 1, 0, 1. And that's our binary OR. Further, we have a binary AND. So here we've got an AND between C and D. So here we'd have 1, 1, 1, 0, 0, 0, 1, 1. And B is 0, 1, 0, 1. Sorry, I haven't lined these up very well. 0, 1, 0, 1. And we're going to AND them together bitwise. So 1 and 1 is going to give a 1. 1 and 0 is going to give a 0. A A 0 on 1 is going to give a 0. A 0 on a 0 is going to give a 0. A 0 on a 1 is going to give a 0. A 1 and 0, sorry, they're not lined up, is going to give a 0. A 1 and a 1 is going to give a 1, and a 1 and a 0 is going to give a 0. So that one here would give 0, 1, 0, 0, 0, 0, 0, 1. And that's our bitwise AND. Okay? You can't swap these around and because they do something very different. Okay? Now, the next one is a little bit different. This is an exclusive OR, and you'll often see it written as XOR. Okay? So an XOR, an exclusive OR, is basically like an OR, but they both can't be 1. Okay, so they both have to be different to get a 1. So let's have a look at that. So we've got A XOR C. So we've got 1, 1, 0, 0, 1, 1, 0, 0. And we've got C, which is 1, 1, 1, 0, 0, 0, 1, 1. So if we have a look at this, 0 or 1 would give us a 1. 0 XOR 1 would also give us a 1. Okay? A 0 XOR 1 would also give us a 1. They're both different. We get a 1 XOR 0, that would also give us a 1. A 1 XOR 0, which would also give us a 1. A 0 XOR 0 or 0 or 0 would give a 0. Okay? A 0 XOR 1 gives a 1. And this is the difference between a OR and an XOR. A 1 or 1 would give a 1, but a 1 XOR 1 gives a 0. So a 1 XOR 1 gives a 0. So when they're both the same, either 0 or 1, it gives a 0, but when both are different, it gives a 1. So here we'd get 0, 0, 1, 0, 1, 1, 1, 1. The next part is probably one of the easiest ones, and this is a bitwise NOT. Okay, and this is a unary operator, like the increment and decrement that only worked on one operand. The bitwise NOT is the same thing. So here we have C, which is 1, 1, 1, 0, 0, 0, 1, 1, and bitwise NOT would give just the complement, which would be 0, 0, 0, 1, 1, 1, 0, 0. Okay, so it just inverts those bits. So we get 0, 0, 0, 1, 1, 1, 0, 0. Now, with all of this, this can get really confusing, and to solve problems, it can sometimes be quite difficult. It's good to understand the basics of this, but in the next video we're going to show bit manipulation, which is an easy way to implement the manipulations of bits without worrying too much about all these operators. So definitely watch that to learn how to do bit manipulation. Alright, thank you.